If I asked you to graph y equals secant x, of course we're going to use its reciprocal. We know that secant of x is 1 over cosine x because they're reciprocals. So if we're going to graph secant x, first we'll graph cosine x sort of as the bones that go below the actual muscle and tendons of the secant curve. And then we know that zeros become vertical asymptotes, and then maxes become mins, and mins become maxes. And again, the idea of this is if you have a y value of negative 0.1, its reciprocal is 1 over negative 0.1 or negative 10. So a small negative number has a relatively big negative reciprocal. And if I have a number like 100, that's positive 100, its reciprocal is 1 over 100 or 0.01. So you can see a big positive number has a small positive reciprocal. And 0, if I take its reciprocal, is undefined. So that becomes a vertical asymptote. In other words, these rules aren't arbitrary. There's a reason why we're doing this. In order to graph the secant curve, first thing I do, graph the sine curve. Max, 0, min, 0, max. I went to the right. You can see it's an even function because whatever happens to the right of the y-axis happens to the left. Max, 0, min, 0, max. Let me just do that. So if we know that this is 2 pi here and this is negative 2 pi here, that means this here is pi and here is negative pi. And that means this is pi over 2, and here is 3 pi over 2, and here is pi over 2, and here is 3 pi over 2. That will allow us to put down our vertical asymptotes. Now, you see I did a little bit less this time. As long as you get one full cycle, you're good to go. So if I draw in a vertical asymptote, what's my rule? I'm very sure to label it. I don't just leave these vertical lines without saying what they are. First things first, zeros, where the function value is 0, we're going to have vertical asymptotes. So that's going to be at x equals pi over 2, and x equals 3 pi over 2, and x equals negative pi over 2, and x equals negative 3 pi over 2, and on. They go forever in both directions. Last thing I do is I say, well, max values become min values, just as we did with the cosecant function. Max becomes mins, and mins becomes max. And I could finish it off here. We're going to have something that looks like that. And here, min becomes max. I'm going to save my marker. Min becomes max, and max becomes min over here. And so I need at least a couple points. So this hit, because the amplitude of the cosine function is 1, this would be 0, 1 here. And here this is pi, negative 1. And here is 2 pi, 1. And here is negative pi, negative 1. Why don't we finish it? Negative 2 pi, 1, etc., etc., etc. As I said before, the secant function is the green function. I don't mind if you leave that blue cosine function in there. That's the bones that helps you erect this secant function. But really, if you want to see what does the secant function actually look like, here it is. It looks a lot like the cosecant function, except that the u's are in different places. You can see by me labeling these points, you can see they're in different places. And you can see that we have symmetry across the y-axis with cosecant. We said earlier, and now you can see the graphs. I should have left that up there. But certainly, you can see now that cosine of negative theta is equal to cosine of theta. And here, even more starkly apparent, is that secant of negative theta is equal to secant of theta. We said earlier in the course that these were the only even functions. And you can see now that they're drawn together, you can see that whatever happens here, they have symmetry across this y-axis. That's why they're even functions.